We don't have too many sessions left. I've saved a couple of the really good ones for the final days here. Today we're going to talk about AIDS testing, and you might have, the first question that might come to your mind is, what in the world does AIDS testing have to do with introductory topics or mathematics at all? And hopefully I'll make that clear in a little bit. To do this, and this is the only thing we're going to do today, we're not going to do an extra session on anything, but I want to introduce you, now that we've talked a little bit about probability, I want to introduce you to tree diagrams and how we can use those to do problems. For instance, in this particular situation, pardon me a second. In this particular situation, we have 30% of girls like to play softball. Of the girls that like to play softball, 75% like math, and of the girls that don't like to play softball, 60% like math, and so on and so on. We're going to make a tree diagram, something like I've shown you here. And so we will once I get my light to work. It doesn't seem like it's going to work. I guess we'll live without it. All right, so we're going to make a tree diagram for 40 girls and answer questions about it. All right, so first, we know that 30% of the girls like to play softball. So if there are 40 girls, 30% of 40 is 12. So we have 12 girls that like softball, okay? We have 70% of the 40, which would be 28, or you could simply subtract the 12 off of 40, and I get 28. 28 do not like softball, okay? All right. Now, of the ones that like to play softball, 75% like math. So 75% of 12 should be 3/4 of 12, which is, I think, 9. So 9 like math, and 3 do not like math. Yes? Okay? Of the ones that don't like to play softball, 60% like math. So might need a calculator for some of these. So I'm going to take 60% of the 28, so 28 times 0.60, I get, try that again, 28 times 0.60, I get 16.8 like math, and I can subtract this off, or take, if 60% like math, 40% don't, so 28 times 0.40, I get 11.2 do not like math, okay? Now, we want to be able to answer questions for this particular tree diagram. Okay, and now to answer the questions about this, here's once again the problem, all right? We've set up the branches as I've detailed here, 30%. And 70%, the second branch is 75% of the 12 like, or 9 and 3. On the lower branches, 60%, 16.8 and 11.2. So now the questions. If a girl likes softball, find the probability that she likes math. Well, here are the girls that like softball. There are 12 of them. The probability that she likes math is 9 out of the 12. Okay, and I think the problem even said 75%, 9 out of 12 is 75%. Some of these questions are going to be incredibly easy. Some of them are going to be a little tricky. Like, if a girl does not like softball, find the probability she likes math. If you don't like softball, there's 28. The ones that like math would be 16.8 out of 28. 16.8 divided by 28. And that's the 60% that we talked about. So it works. Now, here's where it gets interesting. If a girl likes math, what is the probability she likes softball? So let's look at the girls that like math. Here are the girls that like math. 9 and 16.8 is 25 0.8. What is the probability that she likes softball? Well, which of the ones here that I just added up like softball? Isn't it the 9? So the 9 goes on the top, and it'd be 9 divided by 25.8, which is about 35%. Okay? That's the way you do probability with a tree diagram. Let's do another one. Okay, of 50 students, 70% like McDonald's food. So here we are, 70% of 50, you can almost do that in your head, that's 35 like McDonald's. We know then that 30% don't like McDonald's. So you could take 30% of the 50 and get 15 for this branch that don't like McDonald's, or you can simply subtract 35 off the 50. So I have 15 do not like McDonald's food. Okay? Now, of the ones who do like McDonald's up here, 30% also like Arby's. So 30% of the 35, I think that's 10.5, like Arby's. And if you subtract this off, 10.5 off of 35 is 24.5. 24.5 do not like Arby's, okay? Or you could have taken, if 30% like Arby's, you could have taken 0.70 times that, if you don't like the subtraction that I'm doing. Of the ones that don't like McDonald's, it's 50-50, okay? 50% like Arby's, so I know it's 7.5 like Arby's, and 7.5 do not like Arby's, okay? Let's see if we can answer the questions. If a student likes McDonald's, here are the ones liking McDonald's. What's the probability they'll like Arby's? It's 10.5 out of 35. We already know the ones who do like it is 30%. Just to double check our work, it should be 10.5 divided by 35 is 30%. Works good. If a student likes Arby's, what is the probability they'll like McDonald's? If a student likes Arby's, here are the two that like Arby's. So a grand total, isn't that 18? Liking Arby's, what's the probability they will also like McDonald's? Which one like McDonald's? Right there, the 10.5. So 10.5 divided by 18, and I get about 58% chance that they will like McDonald's. Tree diagrams. Okay? We're starting to get a little closer to the AIDS testing. Okay? All right, so let's go through this one. Suppose it is known that 20% of high school students have tried an illegal drug. They institute a drug policy that's pretty accurate, 99.8% correct, with only 2.2% false positives or false negatives. Set up a tree diagram for 1,000 students. And we want to find out if a student tests positive, what's the probability that they actually have used drugs? Okay, you would think it's probably pretty high with as accurate as that test is. All right, so here we go. So we have 1,000 students, okay? 20% of them have tried an illegal drug. 20% of 1,000 multiplied 0.20 times 1,000. 200 have done drugs. 800 have not done drugs. Yes? Okay? Now they're tested. They are tested. So of the ones that do drugs, it's 99.998% correct. So the ones that do drugs, I'm going to take 200 times 0.998, and 199.6 would test positive because they do drugs and the test is accurate. 0.002, you could take it times that, or just subtract this off of 200, 0.4 would test negative. It's a false negative. Okay? Set up a tree diagram now. This branch, for the ones that don't do drugs. If you have 800 that don't, so 800 times 0.998, shouldn't that give us the ones that test negative because they don't do drugs, which is 798.4. Don't do drugs, so they're going to test negative. And I can either multiply this times 0.002, or I can subtract that off of 800, which I think is 1.6, should be a false positive. Okay? All right, so now the question. If a student tests positive, here are the ones that test positive. See them? So I've got 199.6 plus 1.6 testing positive. That goes on the bottom to 1.2. What is the probability they actually abuse drugs? The 199.6 goes on the top. Divided by 201.2, and I get the probability that they abuse drugs is about 99.2%. Okay? In all likelihood, they do abuse drugs. Okay. Now, that is the way you set up a tree diagram, okay? And I think that'll give you enough practice for what we're going to be doing today. The question is all about today, what if you test positive for AIDS? And because of the false negatives, I thought this video was rather interesting. See if my computer is going to cooperate here today.
This woman had 9 false positives for HIV while she was pregnant. Imagine this horrifying scenario. You're pregnant, so you see your OB-GYN for a regular checkup and she says you're HIV positive. There's no way that could be, right? After freaking out for 2 full weeks, it turns out it was all a false alarm. You panicked for nothing. That's exactly what happened to Jen Morrison of Maryland when she was carrying her second child. In a recent essay for OZY.com, she discusses how a routine gyno visit led to the most terrifying 2 weeks of her life. Here's what went down. After going in for a blood draw, Jen's doctor informed her that she had tested positive for HIV-2, which is typically only found in West Africa. Yet, there's more than one type of HIV virus. Despite the fact that this diagnosis was virtually impossible, Jen and her husband were each other's only sexual partners. She hadn't been to West Africa, and she had tested negative for HIV a year earlier. Her doc was adamant the test had been run 9 times, after all. Jen agonized and obsessed over the idea that she could have contracted the devastating disease through some brief contact in a public restroom or with a mosquito. FYI. You can't get it this way. IV can only be transmitted by direct fluid contact from infected blood, semen, vaginal fluid, anal fluid, or breast milk. Luckily, after a second set of lab tests, she learned that the original diagnosis was a false positive. Apparently, Jen's pregnancy had caused a spike in her blood antibody count, which in turn led to the faulty test result. If the second or subsequent child, a mother can develop antibodies against red blood cells, says Alison Webble, RN, PhD, co-author of Living a Healthy Life with HIV. That has been known to cause false positives on HIV screenings, says Webble. It scares like this might be more common than you'd think. Webble says accuracy depends on the type of test that was used, but notes that, in general, lab screenings are only accurate about 95% of the time. That's a pretty big margin of error. So what should you do if you ever find yourself in Jen's situation? As much as possible, try to stay calm, says Webble. Ask for the lab records, and then insist on getting a new confirmatory test right away. This means giving a new blood sample and having the lab run a new test. The Centers for Disease Control and Prevention recommend getting a proviral DNA test to confirm an HIV-2 diagnosis and an FDA-approved nucleic acid test to confirm an HIV-1 diagnosis.
Okay, what is really fascinating about where we're headed today is I want you to, we're also going to do.
For 3 months,
sorry
Esther
about that.
McCarthy has been on antiretroviral.
I want you to investigate a little bit the whole testing for AIDS and what is really true if you test positive and what is true if you test negative. The work is a little intense today. I went through a bunch of examples to give you an idea how to set up a tree diagram. Make sure you show me your work. Set up tree diagrams for each of the problems, okay? And you should be able to work those out if you follow these techniques, and you're going to find that you are going to have some really, really, really surprising results. So don't hesitate to get in touch with me if you have trouble.